on top of page 104 where it's got the diagram and then it has A times B is equal to C times D. That's actually incorrect. That's why the whole thing threw me out. Can you write the following? So cross it out. That A times B equals C times D. That's incorrect. Okay, what you need to write in place is this. So B times the sum of the whole chord, the whole secant. Okay, so in your diagram, you've got something like this, and you've got A, B, D, C on page 104. So what it said on the thing was this times this equals that times that, which is not correct. Okay, what it is the external point to the first point of the circle. Okay, the length of that multiplied by the whole length. Okay, so from the external point to the second point of intersection. Okay, so that'll be the sum of A plus B is equal to the external point of the secant to the second part of the circle, which is D, times the sum of the external point, the whole interval from the external point to the second point of intersection, so C plus D. Okay, so what's in your notes is not correct. Now that I've got that, now I can see the proof. Okay, so we start from the external point to the first point of the intersection of the circle, multiply that length by the external point to the second length of the same chord, of the same secant, sorry, and it's equal to the same thing on the other secant. Okay, so what we need to do is do a proof. So, in the proof, so we need to show similar triangles. So we're going to go triangle SBC, so that triangle there on the left, and then the triangle SAD on the right there. So that's the two triangles we're going to use. Show they're similar, and then going to use the similar sides and similar ratios, same ratios, to show those two, show that overall property there. So what we're going to show, the SA, this point to this point multiplied by this point to this point, which is SB, is equal to the external point to the first point of contact of the circle, that length, multiplied by the external point to the second intersection of the circle. Okay, so we need to show those two triangles are similar. So the angle at S. Sorry? So the angle up the very top is common because that forms both triangles up there. Okay, so the triangle on the left, the angle SBC, so this angle here, I'm going to call it X, is equal to angle, same down here, SDA. Alright, so you should be familiar with why these two are equal. I think someone's already mentioned it this morning. Okay, so when you have the same arc, okay, you have two chords, intersection, those two angles are equal. So, angle in same segment are equal. Okay. So therefore, we've shown two angles in the triangles are the same. Therefore, logically, the third angle in both triangles must also be the same. Right, so therefore, triangle SBC, remember 3 vertical, is similar to triangle SAD. Which is equal angular, okay? Which means all three angles are equal. So to show similar triangles, you need to show the sides in the same ratio, okay? Or you show that the angles are equal. Right, if I go up the top again, label it Y. just helps me with my diagram. So I'm going to draw the two triangles again. So they're going to look something like this. So I'm going to make the angle X. So I'm sort of taking this triangle here and rotating it around like that. The angle X here and the angle Y down the bottom here. The angle X is B, the angle Y is at the vertex S, and the other letter up the top of this triangle here is the letter C. Okay, so the second triangle, the one on the right, here, if I rotate it around like that, right, so I'm also going to get the angle Y at the bottom. So I've got to rotate it, and also, because I want the angle Y on this side as well, when I rotate it, I have to invert it, okay? Because if I rotate it this way, the letter Y will be on the right, and the letter X will be on the left. Now I want it matching this. So if I flip it over, okay, I'll get my Y, and I'll get my X on the right side. So it's matching that diagram. So in this triangle, without the angle marked with the letter A, so that's the vertex of the triangle in this orientation. Right, the letter Y is that vertex X, and the letter X, is at vertex D. Okay, so I've taken the left triangle, I've rotated around to that orientation. I've taken the right triangle, I've rotated it, and I also have inverted it, so that my angles are in the same position. Right, so that means the overall length of the secant, so from S to B and from S to D, so I've got SB here and SD. That means the ratio SB over the matching side, which is SD. Okay, so I need the shorter one, I need SA and I need SC. So SA is here and SC is the matching side of the other triangle. Alright, so they need to be in order. So left triangle, so SC over SA. Okay, so this side over this side must equal the same ratio as this side over this side, which will also equal the same ratio as this side over this side, but we won't need that for our proof. Right. Now, because the equal signs, we can cross multiply the denominators, so therefore SA times SB is going to be SC times SD, which is what we wanted at the start. That's why I got confused, because it should have been the overall length, not this times this. And that's where I got confused. And looking at the triangle, trying to prove it, wasn't quite working out. Okay, so that now covers all 16 properties that you really need to know. Okay, I would look at the other two. I've never come across them, so don't work yourself up to try and learn them. I hope not, okay? I really do hope not. But like I said, I've done lots of these circle geometry questions in past HSCs and I have not come across it. Okay? So I am going to risk it for now. So on Friday, okay, so everyone needs to go back over and remember all the properties again, okay, because on Friday I've got 8 examples in my notes, and then for the next couple of weeks I'll be having a printout of your assignment, and that's what we'll be working through during class time. We're working through some proof together, okay, and then you'll of course have some to do on your own. Right, are there any questions on anything regarding extension 1?